All right, so I wanted to work through question number 21. This is a tricky one. I was doing it in the review session today, and I had to take a break and think about it a little bit more. So this question reads, a newly discovered metalloprotein which contains 2 atoms of manganese, this is one version of the question, 2 atoms of manganese per molecule of protein is found to be 0.772% manganese by mass. Okay, so what we should look at is we should say we've got a metalloprotein, so a protein, a molecule, I'm just going to call it X, has manganese, Mn, associated with it, and there's 2 Mn per 1 of X. Okay, now the mass percentage is 0.772% manganese, and obviously the remainder of it, the X, is going to be, well, 100% minus 0.772, which would be 99.228% X protein. Okay, now this is a kind of tricky question because we already have our ratio. We already have our molar ratio of X to Mn2, or X1 Mn2. So the way that I'm going to work through this problem is I'm going to figure out the number of moles of manganese and then relate that to my number of moles of X. So I'm going to set this up as 0.772 grams of manganese. Looking at the periodic table, I can see that the molar mass of manganese is 54.938 grams of Mn is 1 mole of Mn. Okay, so what I get here is 0.772 divided by 54.938 equals 0.01405 moles of Mn. Okay, now if I wanted to, which I do, I want to go ahead and set this up and basically place what I'm looking for. So I'm writing 99.228 grams of X, and then I don't know my grams of X, but that's what I'm solving for. It's 1 mole of X. So what I can do with this, so what I'm going to be able to do is I'm going to be able to produce this number right here. And the way that I'm going to do that is I'm going to look at the molar ratio that I've already been provided with. The number of moles of our protein to the number of moles of our manganese. So there are 2 moles of manganese for every 1 mole of X. Now, this formula shows me that, well, here I'm going to erase this stuff up here. I'm going to erase my percentages. One of those percentages was given in the problem, the other one I had to figure out. Okay. Now I'm going to say the formula that I've deduced is X blank to Mn 0.01405. Now, my formula that I've known from the periodic table is we have 1 mole of X for every 2 moles of manganese. So all that I need to do is I need to divide this number by 2, because this number right here is, well, 2 times the number of moles of X, because I know my formula tells me that I have 2 times as many moles of manganese as I have moles of X. So I'm going to take that 0.01405 and divide it by 2. And that's going to be 0.007025. So the formula, let me erase some of this, rearrange it a little bit. X, and my subscript of 0.070 or 0.007 0.025 is the same as this right here. They have the exact same molar ratio to one another. Okay, what do I do with that number? Why did I make that number or get that number? Well, that is going to be right here, 0.007025 moles of my protein, X. Okay, so now a very fair and valid question is, what do I do with that number? Well, what you do with that number is take the mass, divide that by the moles. So my 99.228, I'm going to divide that by 0.007025. 99.228 divided by 0.007025 equals 14124.98221. Now, if you look back at the question that we were provided with, the question told us we have 0.772 grams of manganese. That's 3 significant figures. So we need to write this number in significant figures. And the best way to do that is, well, you would 1, 2, 3, 4. So 1.4 times 10 to the, or 1.41 times 10 to the 4th power is going to give you your value that you just solved for right here, grams per mole. Okay, sorry about that. That was a little bit of a tricky problem. Thank you very much for watching. I hope this was helpful. Have a good one.